Once again, welcome everyone. Thank you for taking time out to join us for this webinar. I'm Summer and I'm the marketing at PTV Group, where we use technology and solutions to solve your challenges and improve mobility and transportation. Just a little housekeeping before we get started. Please be informed that you are now on mute mode as the webinar has started broadcasting. If you have any questions during the webinar, please type them into the question box in your control panel. We will have time to address the questions at the end of the presentation. Today, we present to you this webinar titled Application of PTV Vistro in Preparation of Traffic Impact Assessment, presented by Jacob Carreon. Our presenter today, Jacob, he's a traffic engineer from SMDI, and he holds a Bachelor of Science in Civil Engineering from University of Philippines, Diliman. He was also in the top 7th place for Civil Engineering licensure exam, and his experience includes traffic impact assessment, construction traffic control plan, intersection analysis and design, road safety audit, roadwork safety assessment, as well as PTV Vistro and Visim. This webinar will demonstrate how PTV Vistro's functionalities can be optimized in modeling scenarios when conducting traffic impact assessment, while featuring proposed development in Metro Manila, Philippines. From applying growth factor in modeling future scenarios, up to inputting trip generation, distribution, and assignment, everything is easier, much more efficient, and less prone to human errors as manual calculations are significantly reduced. So now, without further ado, we'll start the presentation.
Good day, everyone. Welcome to today's webinar, Application of PTV Vistro in Preparation of Traffic Impact Assessment. Before I proceed, let me introduce myself and our company. I am Jacob Carreon, a traffic engineer of SMDI Consultants. I am in charge of preparation of traffic impact assessment and traffic management plans. I am also experienced in intersection analysis and design, road safety audit, roadwork safety assessment, and use of PTV Vistro and Visim. SMDI Consultants is one of the Philippines' leading independent consultancy firms. Established in 1984, we specialize in urban transport planning, traffic engineering, and traffic management services. In 2000, we became the partner of PTV in the Philippines. Our main objective in today's webinar is to understand how PTV Vistro is used in traffic impact assessment. Just to refresh our memory, traffic impact assessment is defined as the process of analyzing traffic data to assess effects of a potential development on the operation of the surrounding road network as a new development is expected to generate additional traffic. Basically, the main objective of a traffic impact assessment is to compare the existing traffic condition on the surrounding road network right before the development becomes operational to the forecasted traffic condition once the development is operational. To arrive to that comparison, we use PTV Vistro to model the following scenarios. First, we establish our base scenario from existing traffic volumes and composition and existing road network conditions. And then, we forecast future traffic conditions prior to the operation of the proposed development to establish the future without scenario by applying traffic growth rate, which accounts for projected increase in traffic due to regional growth and development. In this scenario, we usually assume that road network geometry and intersection controls will remain the same as base scenario. However, if there are known projects or plans that will be implemented before the operation of the proposed development, those changes must be incorporated. And then, we establish the future with project scenario by determining the number of trips expected to be generated by the proposed development and adding that to the future without scenario. In this scenario, we will be able to determine the effects of the proposed development to the road network through different criteria such as volume capacity ratio, average delay, and level of service. Depending on the location, local government units or the planning department that has jurisdiction in the area may have different tolerance or acceptance criteria on the worsening of traffic conditions. Usually, LGUs do not grant consent to proposed development which will worsen traffic conditions. In those cases, we can recommend traffic management measures such as change in priority in intersections, additional lanes, change in lane assignments, or even traffic signalization to bring the traffic conditions to the same level as without project scenario. Now, here's our TIA checklist of the necessary data and information to perform traffic impact assessment. First, the development profile containing the size of development per land use, for example, the number of residential units, commercial area, office area, or retail area, to estimate the number of trips that may be generated by the proposed development. Next, site location, which will bring us the study area and key intersections. Local TIA guidelines usually set the extent of the study area containing the intersections needed to be analyzed depending on the size of the proposed development and its proximity to major roads. And once we determine the intersections, we determine intersection properties such as lane width, lane assignment, presence of pocket lanes, and traffic signal and facing and timing if applicable. Furthermore, we need to obtain the existing traffic traversing the road network in our study area. And then, in establishing the future without condition, we need to know the target year of operation and the traffic growth rate that we will apply on the background traffic. And finally, we need to obtain available data on how we will distribute the projected trip generation to different directions in the surrounding area. Our case study is a high-density residential condominium with 2 towers of 20 floors each containing a total of 1,235 residential units. The site is in the National Capital Region of the Philippines, specifically in the city of Las Piñas, at the northwest corner of what we will call SMDI Road and PTV Road. For now, we can already proceed with how PTV Vistro is used in the preparation of traffic impact assessment. All other information from the TIA checklist will be discussed along the way. So, let's start with the base scenario. As you can see on your screens, for the purpose of this webinar, the base scenario has already been set up. The study area has been determined based from local TIA guidelines, which includes only one intersection, SMDI Road and PTV Road. The other two are not intersections. They represent the proposed entry and exit driveways of the proposed development. The proposed development will be located in this corner. The intersection currently has a two-way stop control wherein movements from SMDI Road have priority over those coming from PTV Road. That is why if you look at the traffic control tab, which is here, in the priority scheme, PTV Road is set as stop, while SMDI Road is set as free. Also, the traffic volumes have already been entered in the base volume input field. These volumes represent the morning peak hour volumes in the intersection. Normally, we analyze 2 peak hours, one in the morning and one in the afternoon, as the directional distribution of traffic is usually a lot different in the morning and in the afternoon. But for the purpose of this webinar, we'll just focus in the morning peak period. Finally, at the bottom of the traffic control tab, it is shown that SMDI Road PTV Road intersection is currently at level of service C with worst movement delay of 24.73 seconds. Next is the future without project scenario. In this scenario, we need to determine the growth factor computed from the traffic growth rate and the number of years. By applying growth rate formula from a traffic growth rate of 1.8% per annum in the study area and the number of years, which is 2026 minus 2020 or 6, The computed traffic growth factor is 1.1130. To model the future without project scenario, using the Vistro file where we set up the base scenario, the first step is to add a new scenario. In the menu bar, in the upper middle part of our screens, we can see an entry field for scenario. And right now it says base scenario, which is the default scenario when using PTV Vistro. If we try to click this drop-down arrow here, it will show us the list of created scenarios. Right now, we only have one, which is the base scenario. As you can see, there is a plus sign button here. If we click this button, a new scenario is added. And this is where we are going to model our future without project scenario. We can rename the scenario by clicking this drop-down arrow here, right-clicking on the scenario, which we want to rename, and choosing rename. Type in future without, short for future without project, and press enter. To navigate through a different scenario, just click on its name in the scenario list. Now we have created a new scenario for future without project. The only step we need to do in this scenario is to apply the traffic growth factor of 1.1130. To do that, just select one intersection at a time. In this example, we only have one. And then in the volumes tab, which is right here, enter 1.1130 in the row for growth factor. We can edit this at the same time by selecting all entry fields at once and typing in 1.1130. And that's it. If we look in the traffic control tab, in the total analysis volume row, we can see that the volumes increased from the base volume input. The differences in the volumes account for the traffic growth in the area. Now at the bottom, we can see that the intersection level of service dropped to LOSD with worst movement delay of 29.17 seconds. After creating the future without project scenario, we are now ready for the future with project scenario. In modeling the future with project scenario, we need the following information. First is the estimated number of trips that will be generated by the proposed development at peak hours. In this case, the number of vehicles projected to enter the development is 103, while the number of vehicles projected to exit the development is 165, for a total of 268 trips in the morning peak period. Next is how these trips will be distributed in the surrounding areas. In this example, our data show that 17% will go north, 40% will go east, 19% will go south, and 24% will go west, and vice versa. And finally, we need to determine the paths within the road network contained in our study area that site-generated vehicles would most likely take going to the north, east, west, and south directions coming from the development and vice versa. In this example, as shown on the screen, the ingress driveway is proposed to be located at PTV Road, while the egress driveway is proposed to be located at SMDI Road. As observed on site, vehicles going to development coming from south and east will come from the westbound side of SMDI Road as represented by the red line, while vehicles coming from west and north will come from the eastbound side of SMDI Road as represented by the yellow line. Likewise, vehicles leaving the property will take the red path going south and east and the yellow path going north and west. Now we can already proceed with modeling the future with project scenario in PTV Vistro. Similar to the previous scenario, the first step is to create a new scenario. However, instead of clicking this plus sign button here, we have to right-click in the future without project scenario and click duplicate to create a new scenario that incorporates the changes we made in the future without scenario, particularly the traffic growth factor. If we click this plus sign button here instead, we will be able to create a new scenario which will start with what we have in the base scenario, so we will have to enter the traffic growth again. So let's select duplicate, and again We can rename this scenario by right-clicking and selecting Rename. Type in future with and press Enter. The next step is to enter the expected traffic to be generated by the proposed development. In the toolbar on the left-hand side of the screen, click the Zone button to produce traffic. As you can see, the cursor has turned into a zone icon. Click at the location of the proposed development, somewhere here. Now we already have a zone numbered as 18. The number is arbitrary. That represents the proposed development that will generate traffic. However, we still need to enter how much traffic this zone is expected to produce. To do that, click on the Trip Generation tab. As you can see, there is a row numbered as 18. In the data entry column, there is a drop-down arrow. If we click that, we can see that there are two options. The first one is rate, while the second one is trips. We have to choose trips because our data on trip generation for incoming and outgoing trips are both expressed in number of vehicle trips. If we are given the total number of trips with percentage shares of the incoming and outgoing trips, we have to choose rate. We can now enter the number of trips in and trips out in the morning peak period, which are 103 and 165 respectively. Now we have to distribute the generated trips to the north, east, west, and south directions. First thing we do is to insert gates that will represent those directions. In the toolbar, click Gate. Observe that the cursor has turned into a gate icon, and then click somewhere in the north. Then repeat this step for the east, south, and west directions. In the Trip Distribution tab right here, observe that there are entry fields for trip shares from each gate to Zone 18 and from Zone 18 to each gate. This is where we have to enter our data for trip distribution. From what I have shown earlier, 17% of the trips will come from north, 40% from east, 24% from west, and 19% from south, and vice versa. So we just have to enter the same values in the next column: 17, 40, 19, and 24. After distributing the trips, we have to reflect the expected paths that site-generated vehicles will most likely take going to the north, east, west, and south directions that were shown in our screens earlier. In the toolbar, click Path to create paths connecting the zone to the gates and vice versa. First, click on Zone 18, connect it to the egress driveway, trace the path going to the north by clicking at the right directions in the road network, and finally, click on the gate representing north. Repeat this step to create paths going to other directions. Now that I have created paths going to and coming from the other directions, in the Trip Assignment tab, observe that there are 8 rows for the paths that I have created. In the Volume Share column, let's enter 100%. Drag all rows, type in 100, and press Enter. If there are 2 or more possible paths coming from the proposed development to a certain direction, the volume share of 100% must be distributed to those paths based from your available data. But in this case, there is only one likely path for each zone gate pair. That's why we entered 100% for all. That's all for a future with project scenario. If we look into the traffic control tab, we can see that the intersection level of service dropped to E with worst movement delay of 40.08 seconds. Comparing all scenarios, we can observe that the intersection level of service dropped from C to D in the future without project scenario and to E in the future with project scenario. As mentioned earlier, the local government unit or the planning department that has jurisdiction in the area may require physical improvements in the intersection to bring the level of service closer to or better than the future without project condition. To create a future with project scenario with proposed improvements, just duplicate future with project scenario, then rename the new scenario to proposed improvements. Here we can propose any improvement that is feasible subject to approval of local authorities. Improvements may include addition of pocket lanes, widening of the road, traffic signalization, change of intersection control, change of lane assignments, and so on. In this example, I propose traffic signalization which improved the level of service of the intersection from E in the future with project scenario to level of service C with average delay of 23.94 seconds. And that's it. This table may be inserted and discussed in your traffic impact assessment report, or you may generate reports from PTV Vistro and attach them in your traffic impact assessment report, or you may also submit a copy of the Vistro file to the local government unit depending on their requirements. In this webinar, I hope you were able to appreciate how efficient modeling multiple scenarios can be using PTV Vistro, from creating and duplicating multiple scenarios in one file, applying traffic growth factor in one click, inserting zones and gates that generate and consume traffic, up to assigning paths with the aid of visual representation of the road network. Everything is easier, more efficient, and less prone to human error as compared to manual calculation or use of spreadsheets. If you have any questions, please type them in and I will try to answer them. Or you may email me at my email address shown on your screens.
So right now we only have one question. So um, if you have question, like I said, you may type them in and we will answer them. In the meantime, if um, you may visit PTV Group, ptvgroup.com for previous webinars or information on upcoming webinars. So so we only have one question right now. While I answer this question, you may still uh, type in your questions if you have some. So the question is, what is the level of service based on? Is it average delays? In this example, the intersection is a two-way stop controlled intersection. So the answer is no. Um, in Vistro, for two-way stop controlled intersections, analysis is based from highway capacity manual. And according to highway capacity manual, when uh, determining the level of service for two-way stop controlled intersection, the level of service is determined by the worst movement delay. Right? So I hope I have answered your question. Um, if you still have, let's wait for a minute or two for more questions if you have some. Any more questions? Oh, okay, we have another one. What output can we expect? 95th percentile Q. Um, yeah, a degree of saturation. For the 95th percentile Q, yes, it is, we can determine that. Um, we can determine that in Vistro. So if you, as you can see on the screen, there is a 95th percentile Q length. And then for a while, then how does it calculate gap acceptance across single lane and multiple lanes? This question, I believe this is PTV group would be the best ones to answer this question. If you, like I said earlier, um, you can visit the ptvgroup.com for previous webinars, or PTV group will email you about this question, and they will answer this question. So, can Vistro handle analysis of multiple intersections which are close to each other? Um, Vistro can analyze multiple intersections, but it will analyze at this in one network. So Vistro can analyze multiple intersections in one network, but the analysis is independent. So it analyzes each intersection independently. So um, yeah, so I hope I was able to answer your question. So if you want to determine the effects of multiple intersections, it is better if you use VISIM. So let's just wait for more questions. I think we still have time. So another question, how about blocking back in a network if it analyzes them independently? Um, for this one, yeah, I think for this one, I think yeah, the Vistro cannot consider that, but um, I will leave this to the PTV group to answer because they are the best person to answer this question. So PTV will email you, and yeah, but based from my experience, I believe it cannot consider the blocking back. You mean, or you mean the overspill, right? When intersections are close to one another. So yeah. I think it doesn't, but I will leave this to PTV Group to answer. Who are usually the end users of PTV Vistros? Uh, Vistro is best for intersection analysis. So um, in our organization, we use Vistro for TIA or traffic impact assessment for private developments. So and we may also you may also use Vistro when improving existing intersections. So if you have like a intersection that is experiencing congestion and you want to improve the situation by applying traffic management measures, you may use Vistro to analyze those scenarios. So are there any more questions? Okay. Is PTV Bistro useful for TIA of an integrated terminal exchange? Um, it depends on the intersections that it depends on the study area. If you want to focus on a few intersections and those intersections are far away from each other such that one intersection does not affect the other, you may use Vistro. Um, yeah, but personally, I haven't used it. If we will normally for a terminal exchange, I assume this would be like I assume in this study the study area would be quite big, so we might use Visim for this type of TIA. All right, I think we still have few minutes left for questions. So um, if you still have some questions, please type them in. Aside from intersection analysis, what are other applications of Vistro? Um, well, mostly we use this for intersection analysis. I think Vistro is mainly for intersection analysis. So, um, like I said earlier, we can use this for existing intersections that we want to improve or apply traffic management measures. Or we can also use this for traffic impact assessment, which is focused on intersections as well. So I believe Vistro is mainly for intersection analysis. Next, how can we apply the effect of pedestrians and cyclists in Vistro? This is something that I haven't personally encountered, so I will leave this for PTV group to answer. Yeah, I believe they are the best ones to answer this type of question. But uh, but normally when we study pedestrian flows and cyclists, we use Visim or Viswalk. So I personally rarely use Bistro for pedestrians and cyclists. So yeah, so I will leave this for PTV group. Can we apply PTV Bistro for roundabouts? Yes. If you look on your screen, there's a um, control type for an intersection. You may use the if you look on your screen, there's signalized roundabout, always stop, two-way stop, and I believe this topic has been discussed in previous webinars. So if you want, you may visit ptvgroup.com and look for the list of previous webinars, and you may find the more detailed explanation on this matter. Next question, what are the common errors in creating a Vistro model? Oh, this is a tricky question. I'm not sure. Maybe it depends on the user. Uh, Common errors in creating a Vistro model. I'm not sure. Maybe I've used Vistro for quite a while now. That's why I cannot think of possible errors. Maybe, oh, um, a colleague of mine suggested that maybe in the global setting, sometimes people forget to change the global settings. So if you click this edit, then there's the edit menu, there's global settings, and then make sure so every time you do a Vistro um, model, make sure that the global settings is according to the is set to your local standards, or yeah, to your local standards. So for example, the direction of traffic in the Philippines, it's right-hand traffic. So if you're living in a country of left-hand traffic, you may want to change this part. And then the units, yeah. And then common other errors, maybe when entering the data, you might want to double check every time if the numbers you've entered are correct. And the lane assignments, no, maybe not lane assignments. Yeah, I think you just have to make sure every data that you input is correct. So you might want to double check every time. So because if you have created, most especially with your base scenario, when you move from one scenario to another, um, it's like there's quite a lot of things going on. So it's better if you double check every data from every step that you do. So I hope that answers your question. All right. I think there are no more questions. Yeah, like I said earlier, if you still have some questions, you may email me at my um, at my email address shown on your screen. And for the other questions, PTV group will will get in touch with you to answer those questions. Okay. So on behalf of SMDI Consultants, I hope that you have learned something new today and you may be able to apply them in your future endeavors. Thank you, everyone, and have a great day.
Thank you, Jacob, for sharing, and thank you everyone once again for joining us. We appreciate you being here, and we will see you next time. Look out for our webinars. Thank you.